Hello everyone, my name is Nukar Yadav and I'll be talking about image segmentation using deep learning. So as we all know, image segmentation helps us understand the content of an image and is a very important topic in image processing and computer vision. And it has wide variety of applications such as image compression, scene understanding, locating objects in satellite images, etc. So many deep learning models have also emerged since the advent of deep learning in computer vision field. So we will be discussing about them in a while. So yeah, these are the 10 main categories of DL based image segmentation models that I'll be talking about today. So we'll start with fully convolutional networks. So fully convolutional networks, as the name suggests, consist only of convolutional layers where features are extracted by convolving a kernel or filter of weights. It takes, so the basic motivation of FCN is it takes an arbitrary image and produces an image segmentation map of the same size. It uses a skip connections which allow to produce a very accurate and detailed segmentation, as it combines the semantic information from the deeper layers with the appearance information from the shallower layers. And some of the applications of FCNs include iris segmentation and brain tumor segmentation. Then comes the convolutional models with graphical models. As researchers show that deep CNNs have a very poor localization property, which means the responses at the final layer of CNNs are insufficiently localized to produce accurate object segmentation. So what researchers did was they uh, combined the final CNN layer to a fully connected conditional random field, that is CRF, and it was proven to be achieved higher accuracy than the previous FCN methods. As you can see in the diagram also, they connected the deep CNN output to a fully connected CRF to get the final output, which was more accurate than the previous FCN methods that existed at that time. Then comes the encoder-decoder based models. They can be divided into two main categories: encoder-decoder models for general segmentation and encoder-decoder models for medical and biomedical image segmentation. So first I'll be talking about image segmentation, general segmentation models. So they consist of an encoder and a decoder. And encoder, as you can see in the diagram, the encoder uses convolutional network and the decoder uses a deconvolutional network, which generates a map of pixel-wise class probabilities based on the input feature vector. And the like most popular models in this category were SegNet and HRNet. Then comes the encoder-decoder models for medical and biomedical image segmentation. UNet and VNet were the two most popular models in this category, which were used for medical and biomedical image segmentation. The UNet basically use the segmentation, use the data augmentation techniques to learn the available annotated images, which help us to improve more accuracy. And it basically consists of two parts. Uh, contracting part and a symmetric expanding part for capturing context and enabling precise localization respectively. So as you can see here, it's using a conv 3x3 ReLU and a conv 2x2 filters. Then VNet is another popular model used for 3D medical imaging segmentation, and it main idea behind is that the model was trained, which was based on dice coefficient. It takes the MRI volumes and predicts the segmentation for the whole MRI volume at once. So as you can see here, for down convolution, it uses a 2x2 filter with stride 2, and for up convolution, it uses a 2x2 filter with stride 2 as well. Then talking about the multi-scale and pyramid network-based models, so the basic idea behind this is like it constructs feature of pyramids and uses a bottom-up pathway, a down pathway, and lateral connections to merge a low and high resolution features. As you can see in the diagram, which represents a block illustrating the lateral connection and the top-down pathway merged by addition. It uses a 3x3 convolution on concatenated feature maps to produce the output of each stage, and finally the stage of each output stage generates a prediction to detect an object. Then talking about the regional convolutional networks, for instance, segmentation. It well addresses the problem of instance segmentation and performs the task of object detection, semantic segmentation simultaneously, which is quite an interesting thing. And it extensions faster RCN and uses a regional proposal network RPN to extract a region of interest, and then uses a ROI pool layer for feature computation from these proposals and for the bounding box and coordinate and class of the object. Here you can see in the picture faster RCNN architecture, where it's using a ROI pooling for feature computation from the proposals. Talking about the dilated convolutional models and deep lab family, which have been a state-of-art models for image segmentation. They actually have an additional parameter in addition to convolutional layer. They have a dilation rate, which defines a spacing between the weights of the kernel, and are very popular for real-time segmentation. Among the deep lab family, like deep lab version 1, version 2, version 3 are version 3 plus are state of art models for image segmentation approaches. Deep lab version 3 plus is the latest one, and basically the use of dilated convolution, they have three key features. First is, like as mentioned, use of dilated convolution to address the decreasing resolution in the network, which is caused by max pooling and striding. Then atrospatial pyramid pooling, which props an incoming convolutional feature layer with filters at multiple sampling rate, and thus capturing objects as well as image context at multiple scales to robustly segment objects at multiple scales. Also, it has improved localization of object boundaries by combining methods from deep CNNs and probabilistic graphical models. So they were the best models for image segmentation approaches, and the best deep lab model, uh, which was using a ResNet 101 as backbone, reached a 70.4 MIOU score on Cityscape image segmentation dataset. Then comes the recurrent neural network based models. They potentially improve the estimation of segmentation map by modeling the short and long term dependencies among pixels. In this category, RESEG was the first RNN based model which was used for image segmentation, and it was developed from ReNet, which was used for image classification. ReSeg model uses ReNet layer, which are stacked on the top of pre-trained VGG16 convolutional layers that extract generic local features to perform image segmentation. In diagram shows the ReSeg model. The pre-trained VGG16 feature extractor is not shown here, but it's stacked. The ReNet layers are stacked on pre-trained VGG16 convolutional layers. Then talking about the attention-based models, the attention mechanism actually has been very popular in computer vision field, and it outperforms average and max pooling, and it enables the model to assess the importance of features at different positions and scales. As you can see in the diagram, attention-based semantic segmentation model, and it assigns different weights to different scales. So here, as you can see, the model assigns large weights to the smaller person, and which is like green dashed line, and then for features from scale 1 and large weights on the large child, magenta dash circles for features from scale 0.5. Then generative models and adversarial training. In adversarial training approach, a convolutional semantic segmentation network is trained along with adversarial network that discriminates the ground truth segmentation maps from those generated by the segmentation network. This approach has proved accuracy on Stanford background as well as Pascal Walk 2012 data sets. Lastly, we have CNN models with active contour models. The FCNs along with ACMs have recently gained interest, and it's an ongoing research. One of its approach involves formulating new loss functions inspired by the various ACM principle, whereas the other approach utilizes ACM merely as post-processor of the output of FCN, and several efforts attempted modest co-learning by pre-training the FCN. Then we have this diagram which shows the most popular DL based works for image segmentation as well as instance for semantic as image segmentation as well as instance segmentation, starting from 2014 till 2019. Then talking about the image segmentation data sets, the most popular image segmentation data sets that have been used can be put into three categories, that is 2D images, 2.5D, and 3D images. In 2D category, the most popular data sets are the Pascal Visual Object Classes, WOC, Pascal Context, Microsoft Common Objects, Cityscapes. Then 2.5D has NYUD version 2, Sun 3D, etc., ScanNet, and in 3D they have Stanford 2D 3D, ShapeNet Core, and Sydney Urban Objects dataset. Finally, here we have a table which shows various models and their accuracies in terms of MIOU evaluation metric on Cityscape dataset. So as you can see, Deep Lab version 3, which has the backbone of exception 71, achieves an accuracy of 82.1, whereas the HRNet version 2 plus OCR received the highest accuracy of 83.7. So yeah, so in this survey, we discussed about various state-of-the-art models for image segmentation using deep learning. And we also talked about the performance characteristic of different models on Cityscape dataset. As we know, deep learning techniques are quite new in the field of image segmentation, but they have proved to be very powerful so far. The only constraint remains that it uses large amount of memory for training and inference, and the models are therefore bounded by these constraints. Although extensive research is ongoing to tackle this problem, and we can expect that in the coming few years we will have new innovations and unique research lines open. Yeah, thank you everyone.